Good morning, everybody. I'm sorry, I'm awfully sorry for being late, but unfortunately, my laptop decided to restart due to updates, and that's why I have to start everything on backup computer. Please tell me, do you hear me well? Do you
Yes,
see me?
Yes.
Great,
yes.
great, thank you.
Never mind.
Okay, give me one more second to start my slides. Do you see my slides now?
Yes, that's fine.
Okay, then um, we have discussed the issues of privacy as some private sphere of human life.
I'm sorry for interruption, Professor. Please, we are not complete, so would you mind checking the waiting room?
Uh,
Because I think Tatiana is there.
yes, yes, sure, sure. Thank you.
Okay, thank you.
So now, when I hope everyone is here, when I hope everything is working, and my apologies again for being late. When I hope you see my slides and you hear me, let's discuss our issues. Um, we already discussed the issue of privacy, like some area of life where we do some dignity and honorable attribution to our sentiments, feelings, information, communication, etc. This area is protected by law, by international documents, from any invasion or interruption. We also discussed the data protection regime with two, to remind you, with two main aims. First, to balance the interest of privacy and security, and that's why the right to access his or her own data was established. And the second aim, to establish the free flow of personal data within some economic or political unions. The first union was European Union, but now there are at least three of them. And in order to meet this aim, two main pillars of this data protection regime were established. The first pillar is data protection principles, like lawfulness, transparency, data minimization, purpose limitation, etc. And the second pillar is legal grounds for data possession. It means data subject consent, public duties, vital interest, legitimate interest, and so on. Today, we will discuss a less legal issue of big data privacy. It means the technology of big data and how it influences these two legal regimes we discussed past 2 days. Big data privacy. Okay, I assume that some of you, at least those who came to this course from data science and high performance programming, might be aware of what big data technology is. Could you give me some clue of what is big data technologies or big data approach to data possession? Okay, you can see the V sign here on the slide, and it's my clue to you what is big data. Because from my legal point of view, big data is about some V's, some words starting with a V letter. It's the high velocity of data, the high speed of data being transferred, processed, changed, updated, and so on and so forth. The second V, I think it's the first V, the main V is volume, high volume of data. We will discuss it on the next slide, but the volume of data processed now is really catastrophic. The humanity never experienced such volumes of data. There is also variety of data. It means the diversity of the different types of data. It may be data from different sources, the variable sources of information. What's one more V? What do you think? The V of big data. Any ideas?
I'm sorry, but would you repeat the question about the big data?
There are some features of big data, technology and big data itself, starting with V letter. The big variety of data.
Volume.
The big volume of data.
Okay.
The big velocity of data processing and of data flows. And what is the final V feature of big data? It's the same that in my definition of personal data. Okay, that's a value, because the whole story about this big data is caused by its volume, its value, because people, for some reason, for maybe 20 years, managed to extract some value from this variable high volume and high velocity data flows. So it's about money. Value means money, some income that you can get from the amounts of data. There are two main factors allowing the technology of big data to arise. First is very low cost of storage of storing data. I don't remember the exact digits of how storage, how cost of storage getting lower, got lower and lower. But the thing is that that now it's less than 1% of 1% comparing as it was 10 years ago. It's 100 times less during the 10 years. And storing big amounts of data is really very, very cheap. Uh, it's not, it may not, I think that's not good just by itself, because here in Russia, the very low cost of data storage causes some law enforcement obligation to internet service providers, to data carriers. They are obliged to store for law enforcement reason almost all amounts of data originated from us being their users. Our phone calls, our messages, our texts, our files, our video conversation, and so on and so forth, at least have to be stored for law enforcement reasons. And for sure, these very large storages are being used for the needs of big data processing. That's the first factor of big data technology coming into life. The second is high compatibility of data. For example, when I started my legal career, it was in the late 1990s, in order to get any document I needed for my legal purposes, I needed to go by feet to, for example, a hive or to a court or to some governmental body to request access to some documents, that even if they were in electronic form. Then to make a copy, no photo, because there were no digital cameras at that time, but by Xerox or just by writing it down. And if I were very lucky, I can give my diskette. I'm not sure you are aware what is it. It's a small and low capacity magnetic disk that were used to store files on it. So if I were lucky enough to have a diskette, and I were lucky enough that the file I wanted was in electronic form, then I get this file onto diskette, and will be able to reproduce it on my computer. So even bringing data together to one profile was very, very hard 20 or even 15 years ago. Now everything is first on the net. Second, in some standardized format, means Microsoft Word format, PDF format, XML format, etc. And this data can be easily matched to each other. And matching of data or aggregation of data is the clue of value for big data. Matching data from different sources is a technology allowing to get some new data from this matched data sources. Okay. Do you have any questions about this slide? No. Then let's move forward. Speaking about amounts of data and data sources, can you read the small letters here on the slide, like high, medium, low, unstructured, structured, etc.? Guys, can you read these small letters here on the slide?
I can.
Yes, great. This is a diagram showing sources of big data and showing how more structured the data is, how it means the ability to match data between different sources and to make that data from different sources compatible to each other, and also showing the 3 V's out of maybe 4, like features of big data from this source. And if we see the first, the more traditional source of data, like archives, so what I'm speaking about when I worked 20 years ago, we see that the information in archives is very unstructured. It's of low velocity because archives and documents in archives are not renewed very often. There is not much variety because it's usually a dedicated archive, for example, for court decisions, one archive, for laws, the second archive, for personal profiles, the third archive. And to match this data, you need to go to different archives and to spend some money, and it's called transactional costs. Also, there is a very low volume of storage in each and every archive. Next is some document storage, like, for example, the document clouds, Google Docs, Yandex, Yandex Disk, or Mail Cloud here in Russia. There is much more variety of these documents, and they are more structured comparing the archive because they use some standardized electronic formats. Nevertheless, the velocity and volume of documents in each document storage is not so much. Next source of data is media, like YouTube or some online cinemas, etc. Here we can see a lot of the big volume of data, the big velocity of data, because any media content is very short-living. But still the variety is very low because there's not so much information can be gathered from videos. Next is business apps. The best example is Salesforce. Do you know what Salesforce is? Salesforce.
I think not.
Yes, Salesforce is one of the most powerful software as a service platform for consumer relations. It's a platform almost all big networks use. For example, it's used by Metro Cash and Carry, by Gap, by H&M, and so on and so forth. It's a business platform containing many applications for logistics, for consumer relations, for claim resolution, etc. And here we can see that again there is not so much progress concerning the variety, velocity, and volume of this data. But if we look at the structuring button, we can see that these were kind of information. The information from this source is much more structured than from the previous sources. Moving to social media, social networks, again, we can see a lot of changes, a big volume of information, low variety and low structure of this information. So it's quite similar for the public web. It means just an ordinary website. And here maybe there is there is more amount, there is bigger amount of data, big variety of data, but it's not structured. Also from we can see it in data storage, but the authors of this diagram decided that the information in data storage, just like Amazon, is much more structured. But what we can see in the two last sectors of the diagram is machine log data and sensor data. It's so-called industrial internet. It means internet of the industry, of some factories, let's say, or from carriers. And here is the Internet of Things. Do you know what's Internet of Things? What Internet of Things is?
It's about connecting different devices remotely with a network.
Yes, it's connecting any gadgets, any kind of sensors, small instruments, etc., to the internet by the use of specific network technology with very low capacity channels, but it can generate a really huge amount of very structured data with a big velocity and a big variety of data. And for sure, all the big data companies, all the big data technology companies are now awaiting of this Internet of Things to be more and more widespread, to get more and more data from it, and trying to earn more and more value or income from it. But at the moment of drafting this diagram, it was about a year ago, as far as I remember, still with the people or consumers generate 70 up to 75% of any data in electronic form. So at least a year ago, Internet of Things or the sensor or industrial data, last two sectors here on the diagram, generates less than 1/4 of each data. It will be bigger and bigger each year, but present? No. Most data is generated from the people. That's why the issue of privacy and personal data protection is very, very important with regard to big data technologies and big data industry. Any questions on this? No. Okay. That's the core issue of balancing personal data protection and big data technology promotion. The name of this issue is profiling. It's the same word in English and in Russian. I already said you, and I say it once again, that the value, the income from any big data technology arises at the moment when you can match data from different sources. The aims of this matching may be different. Here you can see the aims to analyze or predict some aspects concerning human behavior, like economic wellness, health, personal preference, reliability, behavior, location of movements. So the big data technology is about telling the future, not telling the future for everyone, but just telling the future of a very specific person in order to sell him her something, in order to hire him or her for work, to engage as a student, as a client for medical services, etc. And the worst thing here is not only to predict someone's behavior, but big data technologies also are proven to influence on our behavior. It means that these big data companies can not only observe our behavior, our activity, but influence on our activity in order to make us buy something or to act in any way needed for this company. It's not only about the economics, it's also about the politics, because as you may heard, in different countries, these big data technologies were used in order to influence on the elections held in this country. I am not sure they really influenced the results of election, but these technologies were used. These technologies were proven to be effective, and it's only the matter of time when these technologies can be used to influence on the results of elections. So the core issue about big data and personal data is profiling. And the profiling itself is matching data from different sources to predict someone's behavior or even influence on someone's behavior. Do you have any questions about it? a little bit back to our past topic. Here are the principles we discussed thoroughly yesterday. Lawfulness, fairness, transparency, purpose limitation, data minimization, accuracy, storage limitation, integrity and confidentiality, and accountability. Do you think that a big data technology matches all these principles or not? Any ideas?
Well, I think not, because like purpose limitation and storage limitation.
Mm-hmm.
They-
Yes, sure. These two principles are violated in the most severe way, because big data means the data collected for different purposes are being brought together. There is an aim to get as much data as you can, though there is no storage limitation, and there is no economic limitations of storage, because storage is very cheap. Also, the principles of data minimization and principles of accuracy are violated, because big data is about velocity of data, but not about the accuracy of data. There is no way to renew data to check whether the data, these huge storages, are accurate, are correct, are not obsolete. There is no way for data subjects to access the data within the very big volumes of data, and to make some changes, to update the data about them. For sure, it's untransparent for data subject how the data about them are being processed in these big data factories. And to the end, all this process is very, very unfair for data subject, because we don't know what is processed about us. We don't know how it's used. We don't know how the information about us is being spread. And you may recall from our talk on Tuesday that these three collection, dissemination, and use of information are the main factors of harm that may be made to data subject. So the technology of big data is harmful from its nature. It's very important thing about this big data technology. And I may admit that the volume of that the value, that the commercial success of this big data technology is in some way connected to this harmful nature of it, because the income arises on a breaking balance between the needs of data subject, between the interest of data subject and the interest of business. So it's big data technology is quite an unfair business. So what can be done with this, let's call it market failure? First, we need to look on the big data life cycle, because for sure there is some cycle of data. Let's start with the first step here on the cycle. called raw data. It's the data on the networks, on the sensors, on the Internet of Things, on some video surveillance cameras, from media sources, etc. It's high volume, high velocity, and very unstructured data. Then this data is processed and put into profiles. So this arrow is a profiling process where profiles are being made. And on this stage of cycle, big data arises, and it's the most harmful, has potentially harmful stage of this big data lifecycle. But this this process doesn't stop here, because for most cases there is no need for each and every profile be connected to the very specific person, because again we are speaking about big data, the data about all society, or maybe certain part of society living somewhere in the, say, in some region of Moscow, on Cairo, etc. And for this reason, the data can be anonymized. It means by the use of quasi-identifiers, or by use of some, let's say, data mix, or by adding some artificial data to these profiles, the data became no more connectable to any exact, any identifiable physical person. And once it's not connected to an identifiable individual, it cannot bring any harm to him or her. So the technology of anonymization of data is the most promising way to make this big data technology less harmful. The less connection exists between data profile and exact individual, the less probably harm to this very individual can be made. But again, we are speaking about data cycle, and it's possible that by adding some additional information, by matching data from different sources, it means from anonymized data and from, for example, the sources of raw data like cellular networks, a new portion of highly identifiable, of highly profiled, highly, so legal term, singling out data can be made. And on this stage, it can make even more harm by aggregation of more and more amounts of data. So this very stage is necessary, but it shall be passed as soon as possible to anonymized data that can be used by market itself. And that's why this big data stage of this data lifecycle shall be treated very carefully by the states and by the market itself. And at this time, at this stage of our talk today, we need to look at the players, at the participants of these big data relationships. At least there are 4 of them. And we need to understand what each of them is doing in order to realize what can be done with all of them. First type of players are data collectors. There are banks, telecom carriers, application developers, etc., etc. They are the companies dealing with the initial sources of data. It means with the people. And these data collectors were the persons, were the companies that specify the initial purposes of data collection. And it's very important to make the data processing fair for the subject, at least at that stage, that all the information of how the data will be processed further will be clear for data subject at this stage. And that's why it's needed to to make data processing policies, to update them, and to make users be familiar with them. Next type of player is a data market. It's a platform when data from different sources, from different platforms, are being matched and sold. There are a lot of them. Here are the examples of them. You may check these examples after our talk. Also, there are data users, companies that are trying to make some value of big data, not just like money, but by elaborating some new technologies, by making some new services or new applications or some gadgets, etc. And that's again a very important stage of the very important player, and the activities a very important stage of big data lifecycle, because it's the main source of public wealth for big data. It's not only for money, but it's for making our life better, for making our environment better, etc., etc. And these companies really need big data to make our life better. And it's very important to monitor and to structure the transfer of data between data collectors through data makers to data users, because we, being data subjects, are in some kind interested in the activity of data users. Again, they elaborate services we use, and they make these services and products and gadgets better and better each year by the use of big data. For these reasons, the four kind of player exists on the big data market, so-called data monitors or protectors. In most countries, the role of these data monitors or protectors is performed by governmental bodies like Roskomnadzor in Russia. But again, there are non-commercial and non-governmental bodies in some markets. For example, in United States markets, it's a trust computing group and so-called Trust-E association. And some associations are being formed even in the Russian market. Just to mention, it's a big data association. Adopted the ethic code for big data processing. It's a very interesting document on how big data shall be processed in a fair way. Also, there is a Russian Privacy Professionals Association. It's quite new, but I being part of this association, we are trying to elaborate some standards for data processing within also big data technologies, again, to make it lawful, to make it fair, and to adhere in as much as we can to the principles of traditional data processing. Speaking about the countries, the different countries and different approaches. Again, here in the European Union, the main approach is to protect personal data. Here in the North America, the idea of privacy is prevailing, but also the idea of business development is very important. And I'll say also a few words about Asian approaches to big data. So, about the European Union. A little bit more than 2 years ago, a new regulation was adopted in the European Union. It's in force for a year and a half now. And again, the main aim of it is a free movement of data. For this purpose, there are some restrictions on first data localization. It means on any requirements in any law to store data within some territory of some country. And also the requirement established by this regulation about porting of data. It's data portability. We discussed it yesterday. Because data portability is a key factor for establishing competition on the data market. And competition is about selling new products and selling new services to any customers, like end users or companies using big data for elaborating their own services. And competition will lead to the elaboration of self-regulation, like self-regulatory codes of conduct and ethicals. That's what we see surprisingly on our Russian market, when the competition between big data companies like big banks and big telecom operators led to the establishment of this code of conduct, the big data ethic code, how to make their processing of data more fair. But unfortunately, it's not about data portability here in Russia, because data portability is more about governmental regulation, not by regulation by the market code. Nevertheless, the issue of data portability with regard to big data market is important because it's a key factor to competition. Speaking about Japan, an Asian approach to big data technology. In Japan, big data regulation is in line with the personal data regulation, and it's even regulated by the same legal act, by the law called the Act on the Protection of Personal Information. The main idea is that any transfer to a third party requires consent of a data subject. But there are some exceptions to these requirements, and the most workable is a so-called opt-out exception, when there is no need to get consent from each and every data subject, but just to inform data subject. And then if somebody doesn't want to, his or her information will be transferred to some big data company, just to object on this transfer. It's called opt-out exception. You are informed, and if you don't want your data to be transferred, you may claim that, no, please don't transfer my data. Also, there is a definition also called anonymous processed information. It's, in our terms, anonymized data. And for anonymized data, Japanese regulation state that this data can be transferred without any obtaining the prior consent of the data subject, because there is no data subjects on the stage. Data is anonymized. That means it's from itself, no longer connected to any physical person. And then no harm can be made directly to this very physical person. And one more regime, one more legal regime, it's California Consumer Privacy Act. Again, there is no regulation of big data technologies on the federal level. It means for the whole United States, but at least on one state now, and maybe two states within this year, because the second state is the state of Washington, there will be some legal acts governing the big data procession. The most known is the California Consumer Privacy Act. It was established in 2010. It came into force a year ago, and it gave the same right for any consumer or individual as it was given to any European citizens more than 40 years ago. The right to access the information about his or her. So under this law, any person can file a request to a business, and the business in response shall disclose the categories of information collected about this individual, and how and from what sources this information is processed, and with whom it's shared. And also an individual can request to delete and to maybe update the information about him or her. Again, here we can see a so-called opt-out exception. It means that information in form of big data can be processed, can be transferred to third parties without prior consent of data subject, like it is in the European Union or here in Russia. But there is an opt-out possibility if somebody doesn't want his or her data being processed. There is a right to exclude his or her information from this data source, from this data storage. Being frank, that's all I wanted to tell you about big data, because the issue is quite important, but it's still under development, and we will see more and more news from this each year. I hope that next year on this talk I will spend much more time describing the new Washington State bill on this big data. technology, but at present it's only a build. There is no full and final text of it, so I can't tell you about it. And hopefully there will be some activities here in Russia to tell you about. Now the old activity about big data regulation, again, it's a ethic code adopted by Big Data Association of Big Russia, establishing the principles of fair possession of big data by Russian IT companies. That's all for today. Do you have any questions?
I have. So you're saying that the traffic, for example, from our phones and our computers are like massively, massive parts of it is just some data from sensors. Is it right?
Traffic from our phones, data from sensor. I'm not sure I catch your question.
Well, you're saying that social media or like media files on the internet, it's less amount of like volume and velocity than sensor data. So sensor data is like how person uses his computer, his phone, the website.
No. Sensor data is the data from the Internet of Things. For example, from your smart refrigerator, from your smart air conditioner, from your smart air filter. Just to give you an example, I have a client who is manufacturer of air filters for homes. It's very they are very popular for big cities here in Russia and especially in Asia, where the air outside is very polluted. And these filters are smart. They can measure the amount of pollution, the amount of carbohydrates. I don't know whether it's exact term in English, углекислый газ, is to say, and measure temperature, adjust temperature. It's operated by internet, remotely, by SMS, etc., etc. And this a perfect example of the Internet of Things sensors. Because if there are, let's say, 100 of these air filters installed in some district of a city, there are thousands of these filters installed in the city, and there are millions of these filters installed somewhere in China. And all these filters measures the exact amount of people being in their rooms where the filters are installed. These sensors measure the exact pollution of this very location somewhere in the city. This big data of how day-to-day life activity exists in general. And the manufacturer says that if a small factory of some a small workshop is established somewhere in the court of some building in a small Chinese town, it is less than 1 or 2 days to realize it based on the information from these air filters, because pollution increases in a very specific way, and it's obvious that something is happened here in this very location. Another example is the coronavirus epidemic. because the amount of these gases changes where when some people is ill in an apartment, and it's quite clear, and these filters see how much people is experiencing coronavirus infection right now in the right place, in the right districts of the city. Again, it's very structured information. It's very specific because it's connected to a specific function of the sensor, smart filter, smart refrigerator, etc. It's connected to the very specific location, to the very specific people being customers of these sensors, etc. So it's a really huge amount of very matchable data, and a lot of information about us can be extracted from this sensor data. That's all about Internet of Things. Have I answered the question?
Well, just for me, it seems strange, but I will search for it. Well, because this is like a database of some text and some numbers, and not a media file that we use to like watch videos and consume information in video photo files. So for me, it seems strange that this sensor data can be a bigger volume than our ordinary things we do. So maybe this is true, and it's interesting for me. I will search for it.
Mm-hmm. Video data is here on this diagram. Here is media. And in accordance with this diagram, I'm not quite sure it's true. We see the same volume and the same velocity here as the volume and the velocity of sensor data. So yes, the volume and velocity is almost the same, but the sensor data is much more structured.
Okay.
Any other questions? Okay, then thank you. I'll try to put these slides on Canvas for you, because again, there are lots of links here you can use to check it out. Then thank you. We will meet tomorrow for the final talk, and please don't forget about your assignment for tomorrow.
Thank you. Bye.
Okay,
Thank you.
thank you. Goodbye.
Bye.